I'm so glad you made it back for the last installment of our trigonometry trilogy. This is the finale. We're going to look at inverse trig functions. What are inverse trig functions? Well, let me give you a little background. Let's say you've got a sine ratio. It's all set up. What does it mean? Let's try to go backwards here. Let's draw the picture. So we have a right triangle, and somewhere in there there's an angle named A, apparently. And A is the angle of perspective. And this is sine ratio, so that means that these two numbers, 4 and 5, are the opposite and the hypotenuse in that triangle. So that means the side across from A could be 4, and the right angle there points me to the hypotenuse of 5. But you'll notice I could figure out even the third side with the Pythagorean theorem. Hopefully you know it. What would it be? It's a what? 4, 5. Know your triples. 3, 4, 5 is not to scale. But I want to know how big angle A is. That I don't know. How do I find an angle if I only know some sides of the triangle? We're going to have to work ourselves backwards here, and that's where the inverse trig functions come in. So this is what they look like on your calculator. You find your sine, cosine, and tangent buttons, but if you look right above those, you will see what are known as the inverse sine, the inverse cosine, and the inverse tangent. Notice they just have a little -1 designation. You please do not read that as sine -1. That doesn't make any sense. The correct terminology is inverse sine, inverse cosine, and inverse tangent. So if you say it wrong, I'm going to correct you. Here's how they work in an equation. You've got your equation all set up, and you want to know what A is. So you've got to get rid of the fact that we took the sine. You've got to take it a step backwards, and I'm going to say you've got to cancel that sine operation. So this is what you do. You put it in parentheses, other side too, and you take the inverse sine of both sides. So the inverse sine of the left side, and oh, I've got to squeeze it in there because it does go in the front, the inverse sine of the other side. All right, now what happens on the left side is ninjas. Inverse sine and sine are inverse operations. What they do is cancel each other. And so that brings the A out. So angle A is going to be by itself. And if I bring down my other side, this is what's going in the calculator. The inverse sine of 4/5. Let me show you how to do that in the calculator. I'm going to delete this thing and bring over the real deal. Okay, so here's how I use it. I have to access it with my shift or my second function, so I'll hit that first. See it there's the sine inverse, and I'm going to take the inverse sine of 4/5. This will tell me my angle measure, 53-degree angle measure. Awesome, so that gives me angle A is 53 degrees. About 53.1 degrees. Let me squiggle that. And so that's how you find an angle measure. You're going to use the inverse trig function. Let's do it with an example. These are the steps. You already know how to do a lot of this. Namely, you know how to find the angle of perspective. Now, note, this is going to be the angle that you're going to be looking for. This is going to be the question in the problem. Identify the given two sides. You'll need to know at least two. And then choose your weapon, sine, cosine, or tangent from the setup. And then you're going to undo the trig function with its inverse. So that's where we're going to go to the calculator with inverse sine, inverse cosine, or inverse tangent to solve our equation. All right, here's a real example for you. Our first step is to figure out our angle of perspective, and you'll see right here, here's the question. We want to know this angle. So let's identify the sides. The side across from it is opposite. And right here, I almost said that was adjacent, but no, that's across from the right angle, so that's the hypotenuse. So using opposite with hypotenuse, I'm saying this is a sine ratio. So let's set it up as the sine of, we don't have a name for that angle, let's just call it angle X. The sine of angle X is equal to the 16 over the 57. All right, so X is trapped in the sine function. We have to unlock that by doing an inverse sine on both sides. Inverse sine this whole side, and inverse sine, again, I got to squeeze it in. Remind me to leave some room for those. Inverse sine that side. So the inverse sine and the sine just cancel, brings that X out. And this is going into my calculator, the inverse sine of 16 divided by 57. Let's grab a calculator. Alrighty, remember to hit that shift button or that second key, depends on your calculator. Inverse sine of 16 divided by 57. How many degrees have we got? Oh, it's only about 16.3 degrees. So that's the value of my angle, about 16.3 degrees. Easy as that. Number 2, let's do this. Here's our angle. So this is our angle of perspective, the one we want to figure out. And opposite we don't care about. We have adjacent and hypotenuse. All right, so we've got the A and the H. That's a or cosine ratio. So let's set this up. Let's take cosine. Again, we don't have a name for our angle. Man, what is with that? Let's call it angle A. All right, the cosine of angle A is equal to our fraction with adjacent 17 over hypotenuse 37. All right, let's take the inverse cosine to pull the A out of that. Do it on the other side. I left a little room, I think. Not a lot. All right, cosine inversed for 1737. So angle A is out. Remember, these cancel. Angle A is out, and we've got the inverse cosine of 17/37 to put in our calculator. Let's do it. We'll take the inverse cosine of the fraction 17 over 37. Let's see what angle this gives us. Our angle is 62.6 about. Our angle A is about 62.6 degrees. See, this isn't bad. Okay, maybe it is. Word problem. Okay, nah, we can do this. According to federal safety regulations, the proper angle for setting up a ladder is to place its base a quarter of the working length of the ladder from the wall or other vertical surface. Okay, what does that mean? Well, if we had a 15-foot ladder, then the working length, according to our diagram, would only be 12 feet. That's because we need to have an overhang just for the safety. So take off the 3 feet from the 15. You've got a 12-foot distance from the top up the ladder to the top support. So right there on the diagonal, we're going to call this 12 feet. How far out should the base of the ladder be set? Well, back up here, it's got to be a quarter of the working length. So if this is 12 feet, we're going to divide that so that we can get a quarter of that length. So 12 divided by 4 is going to make this safe distance here on the ground 3 feet. And of course, this is a right angle. So we know 3 feet out, and we have a right angle. What is the safe angle of elevation? There's that vocab again, angle of elevation. Let's review that. That means you're coming from a horizontal line and then you're going up with the other side. So that's an angle of elevation. We find that right here in our picture. What's the proper angle of elevation for this? This is our angle of perspective. Okay, let's take a second and identify our sides. Our opposite is, again, not something we need. We are going to use the adjacent here along with the hypotenuse. Okay, so this is another cosine ratio. Let's set her up. It's cosine of the angle of elevation. Let's just call it A. Cosine of the angle equals the adjacent leg over the hypotenuse, 3 over 12. All right, so getting rid of the cosines is going to be an inverse cosine. Let's put that in front of both of these. An inverse cosine here. Stick it in the front. I'm going to get my calculator after these cancel, and I'm going to take the inverse cosine of 3 over 12. And that'll be my answer. What's the safety angle for the ladder? Let's punch it in. It's inverse cosine, right? Yeah, inverse cosine of, let's see, 3 over 12. Looks like it's about a 75-degree angle, 75.5-degree angle. I'll just get it. It's about 75.5 degrees. For safety, always be safe. Okay, our last example. This will take you back. About a week ago, we made some cards to help you with the 30, 60, 90 triangle. We just cut that index card in half. I hope you remember that. But We labeled them as 30, 60, 90. Are they really 30, 60, 90? Let's check. What about, say, angle X? Let's take angle X as our angle of perspective and consider that one first. So for X, we've got 5 opposite, and 3 is connected or adjacent to it. And our long diagonal, that's our hypotenuse. If I want to find X, I'm going to use opposite with adjacent. So I'm doing a tangent ratio. And setting it up, it's going to be the tangent of angle X equals, let's see, opposite goes on top. So it's 5 over 3. Now let's inverse tangent both sides of this. I didn't leave room on this one this time. How funny. Inverse tangent there and inverse tangent here on the other side. And yes, these cancel. So X is alone. X degrees is equal to the inverse tangent of the fraction 5/3. Oh, don't forget the inverse. The fraction 5/3. So let me calculate that. All right, punching this in. My angle is 59.0 degrees. Wow. I didn't even know that. That's really cool. That's not 60. I'm not saying it's 60, but it's so close. That's pretty cool. All right, so the angle is 59 degrees. Is it really 30, 60, 90? Unfortunately not, but it's so close. I don't know if I would ever tell. So this is a 59-degree angle. We could do the same kind of thing for Y, or we could just be smart about it. If this is 59 and this is 90, let's just add that up and see what angle Y would be if we subtract from 180. Angle Y is just going to be about 31 degrees. So, okay, it's not a 30, 60, 90, but it's really close. I think that's cool. All right, we're going to leave you with a little video. This is a way to remember everything about trig that we've learned. It's a great review, and it's kind of fun. And remember to do your try these. They're on your foldable, so go there, give them a shot.
Good morning, guys. I am so excited because we are finally going to start our unit on trigonometry this morning. Miles.
Is there any way we can make this more fun or something?
On your mark, ready, set, let's go. Trigonometry, bro, I know you know. I go psycho when I see a triangle. Just can't sit, gotta get tricky with it. Oh, that's it, 3 angles, 3 sides. T-R-I-G, all up in my eye. Soka, Toa, will tell you where to go. You just gotta know about H, A, and O. Everybody looking at a glance at the box. The H while P is sitting across. Theta, theta, is at the eta, eta. So on it, for the look, I don't mark it. Besides, you ain't touching, it's the OPP. Making it tricky, we want you to see. Yo, what's that last side you say? It's gotta be the ADJ. Get tricky with it. Get tricky with it. Get tricky with it. Get tricky with it. What? You wanna solve with a trig? Watch your step, you might fall trying to work this gate. Soka up, soka up, soka, soka toa. In the middle of the problem, don't know which one, huh? You gotta know which angles and sides that are missing and given in the problem. They're the guides. You can come with me, all these problems I've tried. Heard it's hard, well then somebody lied. And soka toa helps you to study, so you know when to use each one. If you got the O and HYP, so let's you know, such a way to go. Let's say now you got the HYP and the ADJ, then cosine's the way, yes, yes, y'all. But there's one more. You got the legs?
That makes it tan.
Getting tricky with it. Getting tricky with it. Getting tricky with it. Getting tricky with it. Roll with me right now. If you need a side, you gotta know 2 things. Okay, let's ride. You need an angle and one of the sides. Issue is, where does X reside? You see it up high, that's how you know to multiply. So easy, you get it on your own first try. Trig to the maximum, I'll be axing them. How about the one time you gotta use division? Only if X is down below. X and the angle will switch, you know. Last case, it's angle find the time. So let's get it, trust. The theta is the goal, get it alone. Calculators will know when I say go. Take the inverse of the numbers on the right, hit equals and show it off. Now you got it. Get tricky with it. Get tricky.